I mean, you're familiar with Gartner, but we are a company that does research and consulting for a large number of organizations about information technology and what works and what doesn't work, and we do a lot of investigation about what people are actually doing and understanding how successful they've been, and try to help people be more successful with their efforts. What we're talking about today, obviously, is the semantic web, but I wanted to do a couple of things. First of all, I didn't know who was going to be here, so I didn't know how much familiarity people had with semantic web, and I thought that it would be a good idea to start with some of the basic concepts and things like that. I also want to try to put this into a larger picture of semantic content and the way we use semantic content in most typical kinds of organizations. It's interesting that the semantic web is something that's actually been around. It's a term that I think Tim Berners-Lee started using in 1994, I believe. And it really, to some degree, was a description of his original vision for what the web ought to have been, in the sense that it was going to be this giant linked database of all knowledge everywhere that anyone had produced, and you would have ways of accessing that information and understanding what it is, computational ways of accessing that information, understanding what it is, and working with that. And in fact, if you listen to him talk about this today, he doesn't use the term semantic web anymore. He actually talks about linked data, right? And so I think one of the things that you just got to start out with here is that you can't separate this from some of the more basic notions of data and how we've dealt with data over time. And so hopefully you'll get a decent understanding of that. What I thought I'd do is just kind of preface this with a little bit of groundwork about semantics and the concept of the semantic web. Talk a bit about the specific technologies and techniques and standards that are new in the context of the semantic web versus what we've been doing in the past around semantics. And just look at, I have a section here that is the advice that we at Gartner give to most of our customers about the kind of general high-level statements about what they should be doing with semantic web right now. You have to understand that in some cases the folks that are working with us tend to be very advanced in terms of their use of information technology. In other cases, they may not be. So some of that advice, that advice has to be tempered by the situation. This is obviously a cozy group here, and I know I do enough of these presentations that I don't need to follow the script. So if anyone has a question, please just shout at me. I'm more than happy to take any questions.
I want to shut the door.
Yeah, by all means, if you can't hear, and if this, I've got a couple of windows open because it was really hot in here before. If anyone can't hear because of that, I can fix that. And I'm going to take off my jacket because I'm also cooking. So the first thing I wanted to just make sure we were all clear on was about semantics and what we mean by semantics. Obviously, this is, again, very oversimplified discussion, but it's, it kind of gets to what I think is one of the hearts of the mental challenges that we all have when we think about this problem, which is that, semantics is meaning, right? It's what something means. And there's a whole body of work about meaning, about how people come to common understandings of meaning, about how meaning is expressed in language, how meaning changes over time, that I am certainly by no means qualified to speak about. But the notion of meaning is what we're talking about when we talk about semantics. The challenge with it, in the context of just computability and information processing, of course, is that I'm unavailable, don't schedule me. Okay, thank you. Sorry about that. The challenge that we have is that we have multiple representations that have similar or the same meanings, right? And when we talk about semantic technologies, many times people get a little bit confused because they think about it in terms of some kind of representation of the meaning, right? But we just have to be real clear that when we do something in a computing sense that we say is semantic, we're not actually doing anything with the meaning, of course. What we're doing is we're saying one of these representations that we have, in this case of the number 4, is a privileged representation. It's the one that we've chosen to be our standard for the meaning, a standard representation of the meaning that we associate with number 4. And so, to some degree, you have to be, the notion of semantics and the notions of things that we've understood in the past, like metadata, are actually very, very similar. The other challenge that you have with this is that metadata and meaning and semantics and things like that as a context, in context, or say this a different way, they are in many ways a result of the context. So for example, right, if we go back to the classic definition of metadata, which is data about data, a lot of times what we collected for metadata was information about where the data came from and who put it in the who put it in the database and when they put it in there, basic stuff like that was very important to understand. If you go and look at any accounting system, for example, and you look at what a journal entry is in the general ledger of the accounting system, it has right in the transaction who put it there and when it was put there, and all that same information. And so from the point of view of the general ledger, that information is not metadata, it's transactional. From the point of view of the classic metadata scenario, that same class of information may be metadata. So one of the key things you have to understand is that there is no way, in most cases, to look at something and say, oh yeah, this is metadata, this is a semantic privileged representation. Right? You can't tell necessarily from looking at it that that's how it's being used in the context of the system that's been built. Another challenge that you have, again, going back to how we've dealt with meaning in the past in many of our situations, is this notion of master data. If you look at most systems in any type of organizational setting, there are a set of, as we've defined it, consistent uniform set of identifiers that you and some attributes about the things that they identify for the core business objects in that organization. In a university setting, that may be students. In a corporate setting, you've got typical employees, customers, products, those kinds of things. Generally speaking, that master data is master data because it has a shared common meaning in the context of that entity, right? Everyone in the organization sort of kind of knows everyone in an insurance company sort of kind of knows what you mean when you say a policy. That's pretty, that's clear. Now, as we've found out over the years, the devil, of course, is in the details, right? And those meanings in practical terms often diverge from each other, again, because of this challenge that what is critical information and what is metadata information that helps you use that information more effectively varies from circumstance to circumstance. And so you'll find in most organizations today, even those with fairly coherent IT strategies, that they will have many, many representations of customer masters that exists around, and that have overlapping but slightly divergent meanings because of the context in which they're used. And so one of the challenges is to sort out, one of the opportunities from the point of view of using semantic techniques is to try to sort out some of those context-related scenarios. Now, obviously, we also have a huge body of information, which most of us, I think, these days associate with the web, that is essentially textual, and that while it has metadata attached to it, in many cases it has different bits of it have different bits of metadata that are associated with it, and the challenge there is to figure out what is it that we can put together. And the notion of the semantic web is to try to give us a basic set of representations and technologies to manipulate those representations so that we can append any kind of metadata to any kind of thing that we find, and then allow that metadata to be used in a computational process. And again, we'll talk about how that works. I mentioned before, Tim Berners-Lee has been talking about this since 1994. And you'd think that now in 2009 we'd be we'd be well along the road to having it put together. But in fact, I think really the grand idea of the semantic web is something that is very, very large. And we'll talk about the details, but it's not, a lot of those grand ideas don't necessarily get realized in exactly the form in which they're conceived. For a very kind of basic notion of what the semantic web is, or what semantics on the web are made up of, there's a basic set of web technology that underlies all of this. You know, the notions of you know, Unicode character representations, of URIs, of XML and schemas and things like that. Then there are some new bits called RDF, the ontology languages, some things to deal with logic that are associated with that. And then there are some bits that really haven't been addressed. You know, one of the challenges we always have with the web are things like trust and authority. You know, if I see some information on the web, how do I know that I should believe it? You know, because anyone can put it there. And that's something that, you know, we don't have, or at least there are proposed models for how to deal with that. But in today's world, most of that is done the way we've traditionally done it. You go to brands. You know, if you see the news story on the Dow Jones Newswire, you believe it. If you see it in the Onion, you know it's not the same thing. So that's, you know, that's that. And even in this case, even if you go all the way down to the basic levels of the technology, there are still some challenges there. One of the major ones is one that's just been kind of sort of resolved in terms of the way that the standards work, and that is just URIs, right? So let's say there's a page out there, I'm Dan Sholler, let's say there's a, you know, www.dansholler.com, whatever page that you know, is me. And somebody wants to append the semantic information pretty to that, right? Now, does that mean that the page is pretty, or does that mean that I'm pretty? Right? You know, that's not clear from the identifier. And I think that points out one of the biggest interesting challenges that we have with the semantic web, which is that, in effect, the web that we have today is a collection of pages, right? The things that are under there are pages. You know, we have models for using them in different ways that we call resources and stuff like that. But you know, at the end of the day, a URI that you can use in a practical sense generally refers to a web page. And when you talk about the semantic web, you're usually not interested so much in the web page. You're interested in a real-world thing, which may be abstract or it may be concrete, but it has, you know, that has some information about it that's represented on that page. And basically, there's a long argument about this in the standards groups, and what they basically came down to was that there need to be essentially a parallel universe of identifiers that distinguish between things that are pages and things that are resources, things that you can talk about. And the idea is that a lot of the semantics will be attached to the resources. And so one of the things that we've started to see cropping up on the web, and you may have noticed this in some of your browsing around if you've been on some of the sites that are using it, you'll see URLs that have little pound signs, hash marks at the end of them. And those essentially say that this identifier doesn't refer to it's called a dereferenceable identifier. There's a lot of detail that goes into it, but it basically says that this identifier refers to a resource rather than this identifier refers to a page. And so, you know, one of, I think, the linkage between those two things is one of the great unknowns, I guess, about the web and about the semantic web. You know, again, trying to drive toward this grand vision of being able to treat the web as a body of data that you can get things out of. One of the challenges is how we cross those links, and we'll talk about some of the approaches that people have suggested at this point. All right, let me just now. The other thing, you know, we're talking about, and again, Tim Berners-Lee's technology, linked data, right? So we can't forget all the stuff that we've done over the last 30 years with data. I mean, there's a lot of stuff in there that's actually semantic content that can be used in more computational processes than it is today. And you know, one of the challenges is that it ranges everywhere from, you know, field descriptions in the database all the way through to, you know, sometimes rather abstract things like information retention policies, right? That, you know, that are difficult. And so I think it's very clear that for the foreseeable future, as we start to adopt these semantic web technologies, they are not going to replace most of the techniques we have to deal with metadata, to deal with semantics in a typical IT setting, but they are going to be used as an augmentation of that. You know, if we look at organizations right now, you know, a lot of them have what they call metadata repositories about their databases that they've got. Many of them are in the process of developing service registries and repositories as they move toward a kind of service-oriented architecture model for how they're deploying their systems. There are various others, you know, there could be a laundry list there. I didn't put all the various points, but those are some of the key things. And I think that the semantic web is going to just be an augmentation of a lot of that, you know, not at all a replacement. Now, one of the interesting questions about, why do we even need some new stuff to deal with semantics? I mean, we have this really cool language framework, XML, and we can basically, we've all been told, and we've proven in some cases, that we can describe almost anything with an XML vocabulary. So why is it that we need some semantics? Well, in theory, you probably don't, but in practice, there's a lot of stuff that it's extraordinarily difficult to express in XML as it exists today. So, I took this is a colleague of mine who actually created this slide, so I figured I'd give him credit, right? And everyone who looked at that immediately saw that that's a business card, right? So it's very clear that this is somebody who works for Gartner, and that that title of research VP is a reference to their position in the organization. You may have some questions about it, like how to pronounce his name. It's actually Curly is his last name, and why his phone number isn't on this business card. That things like that might come up. But in general, that that kind of thing is there. The way this is represented on the web today, though, is in some either HTML or XHTML type representation, which doesn't actually include any of that information, right? You cannot tell from that table description that he works for Gartner. Because there's some image there that puts that logo on the picture, and it doesn't mean anything. It's not useful. And there's all sorts of other things that you can't tell. And it's very clear that this while that representation has done a phenomenal job in allowing us to create visual things that human beings can consume, it really isn't very good when you try to get a machine type of logic to infer some things about that information. And so what we really need is a different kind of representation that's much more similar to, the analogy is that a lot of the IT folks take is objects and subclasses and things like that. That's one form of that relationship can take. But the notion that, on top of this, there should be something that says Gartner, companies, Gartner, they have employees, there's an employee number out there, that employee is an employee of Gartner, it has a name, he has a location where his office is at, it has a picture of him, all that kind of stuff, right? That would be a much more computable way of dealing with the environment. And really, this is the notion of making the semantics, or some of the semantics anyway, explicit in the structure that would then hopefully get used to actually create this picture of the business card. Now, I just said, XML doesn't work, except when it does, right? So here's an example of a situation where we've actually built a rich set of semantic content in an XML paradigm. And that's XBRL. For those of you who aren't familiar with it, and of course I'm having a brain freeze on what the acronym stands for. Business Reporting Language, I think, is the XML Business Reporting Language. But what this is an effort that has been going on at least since, I think, 2001. It may even predate that at some point. But it is a comprehensive XML structure that allows you to define financial reporting documents. All of those wonderful things that you can look up in Edgar, and the SEC databases and things like that are capable of being described in this language. And in fact, anything that comes in one of those glossy annual reports that you get every year and things like that, all of that can be described in this language. Now, the thing that you have to realize about this was that the development of this thing, like I said, this has been going on for probably 8 or 9 years now. The development of this thing has been a big deal. There was a team of people, the FASB, the Accounting Standards Boards got involved. There was a whole series of iterations where they built out some of the basic concepts around, what is a balance sheet, what is an income statement, what are the elements that are on that, all that kind of stuff. And they've built that into, they've built up a set of primary terms so that you can understand what things mean in the context of this. There's a whole series of that. And again, it was originally done specifically for consumer and commercial banking, right? It was then extended into other financial services types of reporting that's being done. One of the interesting things about this was that, again, the process required them to get a huge number of people involved. There was there was a set of accountants that started out with the kind of initial concept documents. They then brought in, people to work on things. One of the things you see in the annual report always is the footnotes and the management discussions and things like that, right? That's a whole other set that's not necessarily regulated by the accounting organization, but there's a series of conventions for how people do that. There's management reporting, right? As you know, a lot of the annual reports and financial reports will contain management reporting information that is deemed to be material to the business. One of the ones I know, I saw just recently, the online travel service guys, for example, have something that they call the look-to-book ratio, which is how many times you look at stuff until you buy a ticket. And that's an important ratio for them, because if they can increase that ratio, it's very directly related to their sales capacity. So, those kinds of management reports will be in the environment. And then you've got all the stuff about SEC certification and audit certification and things like that needed to be put in there as well. So, long multi-year effort. And on top of that, one of the other things that happened was that, again, going back many years, I think to 2002 or so, the FDIC, I think, was the first one that kind of spread the word unofficially that maybe they were thinking of requiring people to do their adequacy reporting to the FDIC in XBRL when it was finished. And of course, suddenly then all of the banks got really interested, right? So that was, as you would think. So there was an interesting, not only was this a good idea, but they got a lot of people to contribute to it because there was a bit of a stick behind it to make sure that everybody had common agreement. We've gotten to a point now where, in fact, you can get all of the SEC documentation in this format, right? And they are actually in the process of thinking about how they're going to replace Edgar, the Edgar database, which is basically textual documents that you have to do text searches on, with XBRL formatted documents, which have a much richer set of semantics. It would allow you to do things, it would, for example, allow you to compare companies that have similar footnotes, right? That have done, stock option liability write-downs and whatever, things like that. That's something that's almost impossible to do with the current Edgar database, because you'd have to find the text that was related to that. And of course, all the footnotes are slightly different and use slightly different terminology. So that's been very interesting. The other thing is that this has gone international. I believe that there are 45 vocabularies for the formal reports. I think it was the last time I checked, it was 45. And there are some countries, Brazil stands out as one of them, I know, that have by US standards, very strange reporting requirements, but they've been able, the structure has been flexible enough that they've been able to do that. So here's a great example of how someone has built a whole semantic construct using nothing more than the basic web technology. But you can also hear, I described the process they went through. It took years, and the hard part wasn't the effort. The hard part wasn't figuring out the XML, although that was fairly hard. The really hard part was getting all the accountants to sit down in the same room and agree on stuff, right? And you'll hear me say this over and over and over again. When we talk about these semantic technologies, what we're talking about is that's how you write the semantics down, right? We're trying to come up with a way of writing it down. But you have to have it before you can write it down. And having it is the tricky bit at this point. And it always will be, I suspect. So just to transition to the actual specific technologies that are in the semantic web, the basis of the semantic web is this thing called RDF. And RDF is just nothing more than a data representation that's in triples. Okay? It's a basic triple, a subject, a predicate, and an object. The car has a color which is red. Right? That's very, very straightforward. And you can easily imagine how this kind of thing could be used. Sorry, my builds here. If you look at this one, you can easily imagine, with our business card entry, you could represent all that stuff in that kind of way. There's an employee, he's an analyst, the employee is a person, analysts have phone numbers, analysts have names, things like that. The challenge with RDF is that it's like, what's the right word? I don't know if assembler language is the right analogy here. But it's very, very basic, right? If you have just RDF, all you have are a set of assertions. And that is the entire universe of what you can figure out is if it's explicit in the assertion. So for example, if I had an assertion that said something like, candy apple is a shade of red, right? I have no way of figuring out that a candy apple colored car is a red car, because I don't have anything that describes the relationship between is a shade of and is a color, right? You know, I just don't know what that is. So the only way I could figure out if I had a candy apple car with just RDF is if someone also said that, a red car is if someone also created some kind of transitive property that would exist in this environment. And so a lot of these properties don't exist. There are a few in the basic RDF dialog. There are a few kind of collection notions. There's something called a bag, right, where you can say that there's a group of things that are essentially equivalent for the purposes of this relationship. There's also alternatives. You can say that these two things are mutually exclusive for the purposes of this relationship. But you don't have any mechanism there. The other thing you don't have is you don't have any mechanism to restrict the vocabulary, right? So in the same RDF database, I'm going to talk about RDF as being in databases because, again, it fundamentally is a database construct. And in fact, there are RDF-specific database technologies out there that are being used today. Most of them are being used embedded in other products. They're not used as standalone database stuff. The collection of data, it goes back to this fuzzy line between metadata and data. The collection of metadata that's being described in RDF is a collection of data. It's stored somewhere. I'm just going to call it a database because that's the kind of guy I am. So the idea, I could have something in this RDF database that says, the car's color is red. I could also have something in the RDF database that says the shoe's size is 12, right? There's no restriction on the vocabularies. There's no, you need to have some concepts behind that in order to make that stick. And that's why, this is why I say this is kind of assembler-like. There's very little constraints, there's very little semantics. This is just a database of facts, if you will, that then need to be interpreted based on some kind of semantic model. Oops. Now, an interesting side note to all of this is that RDF isn't the only way and all of this isn't the only way of capturing some of these things. One of the other semantic constructs that are kind of building block constructs, the same way that RDF is, are microformats that exist on the web today. Right, and I think we're all familiar with a number of those, right? We all know what vCard is, for example, and things like that. When someone sends you their address, in an email, you can just load it into whatever you're using, Outlook or whatever that you've got, in this vCard format. That's a standard micro format that provides a semantic interpretation of that data as a business card, right? And so my actual example on the earlier thing, I probably should have had that stuff in vCard format because that would have made a lot more sense. There's a whole range of these things. I mean, from calendar entries, the whole, all those sites that have, where you can vote on the value of a thing and where you can put comments. There's all sorts of formats for that. There are even some, much more foundational things. Those of you who have loaded up someone else's blog list into your blog reader have probably gotten an OPML file, for example. Right? OPML stands for the Outline Processing Markup Language, and it's basically a generic format for anything that can be an outline. And the idea is the blog reader knows that if it gets an outline, that it's an outline of blogs and categories and feeds and so forth. So that's again, these are ways where people do a lot of this stuff. And so, I want to make sure that, I mentioned before that we do semantics outside of the web with a lot of the things that we do with data. I also just wanted to be clear that we are also doing some semantics in the context of the web in a somewhat general purpose and building block way. The issue around this is that it's very much a bottom-up effort. There's no effort made to coordinate the things that are done, for example, for calendar entries with the things that are done for business cards, right? And obviously some of that coordination might make a lot of sense because in many cases when I put something on my calendar, I'm meeting someone that I have a business card for, and I want to combine those things easily. So I think that's you just need to be clear that when we talk about semantics on the web, there are some other alternatives, and there is actually a debate going on. There are people who believe that the whole semantic web effort and the ability to tag things with RDF and so forth isn't really going to go anywhere because instead we're going to have this sort of folksonomy of microformats that will handle all those situations. I think that belief is ebbing. As we've started to see some of both the standards and the technology mature around the semantic web. Oops. Now, I mentioned the fact that the semantic web and the web aren't exactly the same thing. that was obviously recognized fairly early on in this effort. And one of the things that's come out of that is something that has the lovely acronym of GRIDL, Gleaning Resource Descriptions from Dialects of Languages. Gleaning just is great. I've never heard that in an acronym before. But that effort really is focused on how do I take existing web stuff, in XML and XHTML and HTML, and get, and generate RDF descriptors for that. And there's a framework for how you do that. There's some tooling that's being developed, and that tooling has started to be extended to some of the other formats, not just the standard W3C standard formats, but things like JSON and other types of things that we do. The part that seems to have been the most challenging is how do I do that from an actual existing relational database? That seems to be, that's a complicated problem. And again, there are a few technologies that do it, but I think that's a category that has a ways to develop at this point before it's really going to be widely practical. The other piece of the next piece of the semantic web is this thing called OWL, which is the web ontology language. Ontology is a fancy word for a taxonomy of concepts. So a taxonomy is about representations, and they just use the word ontology when it's about meaning. The idea here is that this is a standard language for describing a lot of those constraints that RDF was missing, right? It allows you to constrain the vocabulary, so you can say, these are the concepts to which this applies. And you can do things like say that, has a part of is the inverse of is part of, and so forth. So, or has part is the inverse of part of. And things, so you can add a lot of information that creates a huge step up in your ability to infer things from the metadata that you've described. And this is really where a lot of the focus of, when you talk about semantic web in the commercial world, this is really where a lot of the focus is today. People are building ontologies for specific purposes and specific subject areas and specific applications, and we're also seeing systems whose processing capability are based on ontologies that have been constructed. There are also a whole series of tools and technologies that you can use to build your own ontologies and then have them be used in the context of information that you're describing. There are still a few things that are missing here, though. One of the things that's missing is that there's still a restricted vocabulary of relationships that can be described here, right? So even something as simple as A is between B and C can't really be described in that. Now that's an obvious one to get around, of course. You can be greater than one, less than the other, but there are other types of those kinds of relationships that are much harder to model. There are some challenges with things that vary over time. It's very difficult to say that, if this is new, it means one thing, and if it's old, it means something else. You have to manipulate the underlying relationship to add those attributes as specific things. That's something that we've looked at, and the reason so that's an area where we're starting to get, or we are getting some development. There is a standards effort underway called the RDI, Rules Definition, blah, 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 yeah. The acronym just fell out of my head. But there is an effort underway to come up with yet another layer of semantic rule information that one can layer on top of this to deal with the cases that can't be dealt with in the ontology language. And so, that's part of this. In today's world, what's typically being used in that environment is something called RuleML, which is a markup language that got a fair amount of work from particularly the vendors of inference engine type systems a few years ago. And while it's not very widely used, it's relatively mature in the sense that there is a group of people out there in the world that understand it, and there are a group of technologies that make use of it. So that's what we're seeing in practical terms today. There are a gazillion ontologies out there, some of which are good, some of which are not good, some of which are being used, some of which are not being used. And in fact, even in some cases, for example, the XBRL group is actually looking at developing an ontology to try to convert this whole XML structured thing into an RDF-based kind of semantic web structure. That's early days at this point. There are also a number of groups that are trying to build collections of ontologies. One, again, I was speaking yesterday to a group of the major media company CIOs in New York. And there's an effort out there called Open Calais, which is designed to, Calais like the where you take the ferry from Dover. They're trying to get a group of ontologies. A lot of the participants are in some of the commercial media type organizations, and in particular Thomson Reuters has built a proposed ontology and mechanism for media type properties, for news reports and things like that. However, the reality is today that in most circumstances, ontologies are not things that are in the public domain. They are specific to an organization and a particular application that organization may be using. And so, my favorite example was someone from Dow Jones. They actually have a very extensive semantic tagging effort underway for the newswire business. And this actually started, the reason this whole thing started was because once, many, many moons ago, some analyst at one of their contributing organizations did a Google search on United Airlines and found a story that said the parent company of United Airlines files for bankruptcy. This was in about 1998 or so when this was happening. And they, or maybe, it was about 2000, I guess. And UAL had actually filed for bankruptcy in 98 or 97. I can't remember what the year was. But Google, because of the way it works, if it can't figure out the last modified date on a page, it gives you the current date. I don't know if you ever noticed that. So, so somebody looked at this, said, oh my God, they filed for bankruptcy. This worked its way all the way through the newswire, got published on the Dow Jones newswire. They lost 75% of their value in 3 hours before they halted trading on this. Okay, when they reopened the next day, it was still down 11%, right? Because somebody made a mistake with a date. This is not good. And Dow Jones didn't think this was really good either. So what they did is they put together an effort to try to tag all of the information that was coming in that had the potential to be on the newswire with semantic information. And they started out with a basic set of semantics called the Dublin Core, which is a standard that's been out there for several years now that just describes basic information about publications, title, author, where it was published, when it was published, references, blah, 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 those kind of things. This has grown now. They have 8 service bureaus within the Dow Jones organization on a 24/7 operation. They tag something in the neighborhood of, what is it? It's 5 million photographs and 9 million documents, articles a month that they tag with this thing. It's a whole hierarchical thing. They have a series of text mining and automated procedures that they use, and then they then that gets rolled up into various other things, and it eventually, or if there's any ambiguity or things that they can't figure out, that gets to a human being that actually goes through and reads the thing and figures it all out. That effort, it's a multi-million-dollar effort for them, but at the same time, it's been a commercial boon for them, because now what they can do is, instead of just sending, information about United Airlines, in the packet, they can include information about United Airlines' biggest customers, corporate customers, cargo customers, information about the airports that they use as hubs, information about all sorts of related things that are much, much more specific and targeted than the old-fashioned way of doing it, was that when you send stuff about an airline company, you send stuff about the other airline companies, right? That was the Dun & Bradstreet SIC codes. You just kind of skew things out like that. And so they've had, not only has this been a really good thing from the error prevention standpoint, which is where it started, but it's actually been a very commercially valuable tool for them as they've moved forward. But that kind of use, that kind of use of an ontology is typical for what we see. There are some cases where people are producing shared ontologies, but even in those cases, they tend to be shared among a fairly closed group. There's a fair amount of work being done in the pharmaceutical research area, for example, where where there are ontologies that are being built. But what you find is, even there are ontologies that are being built around compounds that have promise in cancer research, for example. And that's not consistent with the ontologies that they're being built around the compounds in diabetes research, just to take you know, a different thing. You know, and we all know in terms of the way pharmaceuticals work, there's a lot of serendipity involved. You know, I have a relative who's working on using a blood pressure medication as a novel treatment for some childhood cancer. It turns out to be working very well. You know, I mean, that's, you know, but no, this knowledge base that they had built would not have allowed them to discover some of those relationships. The relationships that we have tend to be very, very vertically siloed. They are either vertically siloed or they are very thin and shallow, right? There is a common RDF representation of this Dublin core information, right? And the Dublin core information is very useful information, but it really only goes so far, right? It tells you about publications. It doesn't tell you anything about what they mean, who they might be useful for, et cetera. What we're finding is that the typical use there, when people go to build these ontologies, typically they're also doing them from the top down. You know, it's that I'm going to build a set of capability around a certain subject area that I can then reason over with. You know, I can then for a particular commercial or whatever organizational purpose. It's not that they are, you know, we have not gotten to the point, and certainly both the technology and even the standards have not gotten to the point where we can kind of do this from the bottom up and say, hey, look, I got this whole big mass of stuff. Let's, you know, run it through the engines and see what kind of semantics we can capture around that. You know, all of the IT people that I talk to, of course, would love to do it that way. You know, and I think what we're faced with here right now is almost the same thing for those of you who were around the IT world. It's the same thing that we had with data warehousing many years ago. You know, people started off with this cool concept that said, I'm going to keep around the data that I need for management reporting and decision support and stuff like that. And instead of trying to figure out what data they needed, they said, I'm going to capture every bit of data that exists in the known universe. And of course, usually that didn't work. It was much too expensive and much too complicated to actually achieve. Now, there are a few other pieces to the semantic web puzzle, some of which have things going on and some of which don't. The one that I didn't mention was a query engine. Right? There actually is a query language, a kind of SQL-like language that you can use to inquire about information that is composed in RDF and subject to an ontological constraints. So you can, you know, it has this lovely acronym of Sparkle. And there are tools out there that use Sparkle to augment things like search and in many cases business intelligence type tools as well. And also we're seeing a lot of this being used in the content management systems, you know, the systems that kind of, that one implements applications for manipulating text-based information on top of. One of the things that we don't have, and I mentioned the rules engine, you know, this notion of how I do inferencing across some of these things. I also don't have mediation services. You know, I don't have any description, I don't have any way of describing when I've built a comprehensive ontology of concepts for, say, cancer research, how that relates to the ontology of concepts that I've built around diabetes research, as an example. You know, I don't have any way to do that other than to describe the processing of doing it. You know, I don't do it in metadata, if you will. And so I think that's one of the areas where we're likely to see some new development, but there really isn't much of anything there at this point. And I think, you know, the other thing that's happening, there have been, and I believe our next speaker is going to talk about this to some degree, there's been huge advances in the areas of text mining and our ability to actually automatically glean information from language, natural language constructs. But that, you know, the consumption side of that discussion with the semantic web really hasn't kept pace, I don't think. You know, the tools that we have for using semantic tag information in the context of the semantic web are still fairly primitive, and I think that's where a lot of the development is going to happen. You know, from our perspective at Gartner, we always try to track these trends in terms of, you know, we interact, you know, our customer base is thousands of companies around the globe, and we interact with more of them all the time. And you know, semantic web is something that was kind of in the background for many, many years. And it's only just in the last few months that we've really started to see people saying, okay, I've got a concrete business purpose to which I can apply this concept. You know, help me out, help me understand what I can do and what I can't do and where I can get the technology from. So my expectation is that as those commercial opportunities start to really build up over the next year or two, we're going to see a fair amount of innovation in terms of the tools and technology that are out there. So that's essentially the semantic web. You know, one thing I will point out is that our expectation is, again, going back to the Tim Berners-Lee big world vision, we're not going to get to that for a long, long, long time. I put down 2026 there because I was thinking I'd retire then, but actually I'm still going to be paying for college, so it doesn't help. The point is that we're not, that big vision is a grand vision, and it will remain a vision for any foreseeable future, I suspect, that most of us have. What is going to be interesting, I believe, is that, over the next probably 7 to 10 years, and, that sounds like a long time horizon, but I really think that's about how long it's going to take. We will start to see much broader usage of these technologies in the context of the web itself and with the information that we have. But even then, we're still going to have divisions in all of this, in that there's still going to be things that are built out on top of, microformats. There's still going to be semantic information that is, built out in other ways. That's, the semantics are not going to be integrated and overlapped, because at the individual topic level, they may be a top-down initiative with a coherent set of practitioners, but there won't be any coordinating relationships between those things very much. And it's really gonna, it's gonna take a while for things to happen. On the other hand, you can go out right now and get some really cool stuff that's being powered by this. One of my favorites is, and there's actually an article, if anyone's interested, I can point you to it, about how this works, but there's something called Music Brains out there, which is essentially an ontology for music. And the BBC has all of the stuff that their radio stations do is categorized with this ontology. So you can actually find out some rather fast, things that wouldn't have been impossible to do before, but would have been rather difficult, in the sense that if you want to hear about the cycle of Mahler symphonies that they're going to play for his, 250th? I'm losing track here. Anniversary of his birth, there's this cycle of, they were going to play the complete set of Mahler symphonies, right? Well, you can find out, for example, not only when the schedule is, when those things are going to be on BBC Radio, but also when those same performances have been aired before, if they have other performances that the same orchestras have given of Mahler symphonies, other performances that those orchestras are giving of different types. You can actually very easily discover many of these kinds of relationships. And I think that, that's an example where a semantic technology really has powered up a very, sort of what you think of as kind of a simple consumer-facing type of application. And I suspect that we're going to see people recognize more and more of those things over the next few years. I do want to go back to one point I made before, which is about meaning, right? Okay, all of this is really cool, all of this is really great, you still have to agree on the meanings. And there are many counterexamples, unlike Music Brains, where we don't have an agreement on the meanings. These are, I believe, the 7 ways in which medical diagnoses are encoded in the United States. That list gets longer if you go outside the US. Right? There's a series of taxonomies for how you encode medical diagnoses. So, at the end of the day, I just want to end up with this. Again, we're talking here about how you write it down. The really hard part, if anyone's interested in going ahead with this stuff, is actually coming up with the way of agreeing on the meaning and making sure that that agreement can stand and hold over time as the meanings change and as the use cases change. So that's the tricky bit. Once we get to the conversation about technology, you're there. Hopefully you've already figured it out. The other thing, though, that's real clear, and this is just coming from my experience in working with Gartner, is that it's not a technology-led thing. Bringing in the technology is not going to help you figure this out. Right? You have to understand what it is, what information you're trying to deal with. And this is, again, why the taxonomies the ontologies rather, tend to be very narrow. Just a final point, too, that I make for many organizations. You can't forget about all the other metadata and semantic stuff that we talked about in the earlier part of the presentation. And it's important that if you think about moving ahead with the semantic web, you also include in that thinking, how do I relate the stuff that I'm doing for this particular semantic web project with all of the stuff that I have in my metadata databases and data dictionaries and all the other places where I keep semantic information. That's, that becomes critical. And one of the things that, is a separate track of conversation, there's something that, a set of practices, I guess we call it, around enterprise information management that make doing this much easier if as you can establish some baseline and coherent ways of working with the information that the organization holds. So that's it. I know we're out of time. Thank you for being here. And if anyone has any questions, I'll be around for the for certainly through lunch and for this afternoon. So I'm happy to help out in any way I can.